Right, in this lesson, we shall be looking at this particular question, and also we shall look at how questions pertaining tangents are asked in Euclidean geometry, and we proceed to look at the past exam question. Right, in the diagram, A, C, and D lie on the circle with center O. Right, here is the center of the circle. A, E, and D, E are tangents. You can see A, E, and D, E are tangents to the circle at A and D, respectively. ACD is 68 degrees, so you can see ACD, right? So this angle here is given as 68 degrees. Just take note of that. State all relevant reasons with your statements. We need to prove that AODE is a cyclic quad. Right, here is AODE. And we want to prove that this four-sided shape is a cyclic quad. But first things first, we note that this angle here is equal to 90 degrees. So we note that angle A1, right, is equal to 90 degrees. Why? Because of tangent perpendicular to radius. Tangent perpendicular to radius. Right, moreover, we have D3 equals 90 degrees as well. Why? Because we can see that as much as obviously this is a tangent, because we have been told that AE and DE are tangents. So in other words, AE is a tangent, is perpendicular to the radius OA, but also this is a tangent, so it's perpendicular to radius OD, so that we have tangent. Right, we have tangent perpendicular to radius. Next. Right, so as a consequence, we have these two angles here that are opposite. So thus, right, thus angle A1 plus angle D3 is equal to 180 degrees. So if we add these two angles, what we're getting is 180 degrees. And now, if this is the case, hence, AODE is a cyclic quad. Right, is a cyclic quad. Why is it a cyclic quad? It is a cyclic quad because the opposite angles supplementary. Opposite angles supplementary. And if the opposite angles are supplementary, then it is most certainly a cyclic quad there. Okay, so we have been able to prove that AODE is a cyclic quadrilateral. The next thing to do is to determine the size of the angle E. Right, want to find the size of the angle E, and we proceed to find the size of the angle E. We remember that ACD angle ACD, this angle here, is equal to 68 degrees when this equals 90 degrees and that equals 90 degrees. Right, so to find the size of this angle here, angle E, we proceed as follows. First things first, we can find easily the size of the angle O2, and we realize that the angle O2 is equal to 2 into 68 degrees. Right, so if it is 2 times 68 degrees, okay, 2 times 68 degrees, and then we have the following clearly here, right, 68 degrees. Why is this the case? Because angle at center, right, angle at center equals 2 times angle at circumference. Angle 2 times angle at circumference, and therefore angle O2. 2 times 68 is 136 degrees. Right, next. So in other words, this angle here is 136 degrees. And at this point, we know that this is a cyclic quad, so that, in other words, we know that AODE is a cyclic quad, so that we can then say that angle O2, so but Right, angle O2 plus angle E is equal to 180 degrees. So the opposite angles, right, of cyclic quad, right, cyclic quad supplementary. So that in the end, then we have 136 degrees plus angle E, which is 180 degrees. And therefore, angle E is 180 minus 36, which is 44 degrees. So that in the end, then we have that this angle here is 44 degrees. Right. So in the end, then if this is 44 degrees, we have found the size of the angle E. Right. So, right, and opposite angles of a cyclic quad, and obviously, see, when you say opposite angles of a cyclic quad, those are supplementary, and hence we have that the angle E is 44 degrees. So we have determined the size of this angle E to be exactly 44 degrees, and the AODE is a cyclic quad, has also been proved here. And therefore, we have solved this particular geometry question with ease. A very interesting question, and this question appeared in the IEB, right? Appeared in the IEB exam, November 2023, paper 2. Okay, right. Thanks a lot to everybody for watching and for joining us, and goodbye to you.